Hello everyone, how are you? Today I would like to talk about a greedy algorithm. Greedy algorithm is a methodology which regard the question to be a sequence of steps, and at each step it try to pick the local optimal solution. This algorithm do not guarantee a perfect global optimal solution because a sequence of local optimal solution may result into a bad global solution. But it's still a good methodology to try because it is very fast to calculate. Okay, so let's have a look. Okay, so let's have a look at example question. Here we have a sample example question. Imagine in a day we try to do multiple tasks, but we cannot do two tasks at the same time. Each task has start and end time, so we got to have a strategy to do most tasks we are able to do. So here in the scenario, you can see task 1 until task 5. Some tasks they overlap together. We cannot do them at the same time. So just by feel, we can have a idea, actually two ideas. So either we do task 1, then task 2, task 5. Or we can do task 1, 3, 4, and 5. Clearly, the second choice gives us better solution, right? So basically, greedy algorithm means we have a strategy and we always try to do a local optimal choice at the current step. Then we got algorithm here is we sort each tasks by their ending time ascendingly. Then we take the first task, we set our current end time is the end time of first task. So the total task we have done so far is 1. Then we just easily go through the list of the tasks. So for each task, if its start time is bigger than my current end time, then I will do it. I will plus 1 to the task count and then assign its end time to the current end time. Pretty easy, right? Yes, then finally, when we go through the whole list, we got the task count as our result. This algorithm, to be honest, we cannot guarantee it always gives us best solution. The good thing from it is it's really quick, really easy to understand. So sometimes maybe we just want a good solution, not the best solution, considering the processing time limit. Sometimes there's some boundary situation will fail our algorithm. Sometimes not. So we just say we cannot guarantee. If we are lucky, maybe greedy algorithm gave us the best solution. Greedy algorithm is always compared against dynamic programming. Dynamic programming regard a question to be different state, and at each state, we have a global optimal solution and store in memory. So whenever later on we try to reuse the solution, we know it is reliable. However, greedy algorithm regard the question to be a sequence of steps. So whenever we pick the local optimal solution, we don't consider what will happen in the future. So Basically, dynamic programming is regarded as a reliable algorithm, and greedy algorithm is regarded as a perfect alternative if you want to save your processing time. Okay, here is the sample question we have already done in dynamic programming video. The question is, we have three kind of coins, 1 pound, 2 pound, 5 pound, and we try to achieve 7 pound. So this time, let's resolve the question with a new idea. Quite easy. We just try to take the max value of coin at each step. So in step 1, we take a coin of 5 pound. Step 2, we take coin of 2 pound. Pretty simple this time. And the processing time is just order n. However, in dynamic programming, we have a perfect solution which is order n to power of 2. So you can see the advantage of the greedy algorithm. But we know this algorithm may not always give us the best solution. Imagine we try to achieve 1,000 pound. Clearly, we cannot trust this strategy. So greedy algorithm is not always correct, but it's a good alternative. How do you feel today's video? Please let me know through comments. I always try to improve my performance, and your response will be really helpful. Thanks for watching, and see you next time.